Welcome to Lesson 1, Entity Relationship Model. My name is Gerald Balekaki. This is our outline. We have the introduction where we're going to look at an overview of the design process. We have an example of a college database. We're going to look at the ER notation. We have an ER model components and also have an example of a conceptual design. Why relation database design is important? Today, in an increasingly data-driven world, it is imperative to organize your data in an efficient storage, in a fast retrieval, and for easy management. A well-designed database serves as the backbone of any application in an organization. Just like an old computing analogy of garbage in, garbage out. If you're planning to implement a poorly designed database, you're likely to encounter a lot of complication, both as a user and a developer. This course covers three key concepts, and we have the ER model, we have functional dependency, and data normalization. And we will look at each of these in depth. We want to start with the design process. This is an overview of the design process. It comes in 5 phases, the first one being a requirement collection and analysis, followed by the conceptual design. We have the logical design, we also followed by the physical design, and lastly is the implementation. In the first step, we focus on collecting database needs from users, and this can be a real-world organization. We get those requirements and we translate them into a relational schema through using high-level diagrams such as the ER model, ERDs, and we come up with a conceptual schema. This schema must include all the functional requirements of an enterprise. We have the logical design, which we also call data model mapping. And this is basically translating the conceptual schema that we just came up with in the conceptual design into a specific database data model. And of course, we're looking at the conceptual schema from the conceptual design into a specific database system data model. And here we also look at having good collection or relation, which helps us to maintain data integrity, or call it normalization of data. The physical design is related with a physical layout of the database on a disk. And here we look at things like file organization. We've looked at indexing or indexing strategies, and also how we place record on a disk. Finally is the implementation, which is our final phase. And here the database is tested, it's implemented, and also it's deployed. Entity relationship model, or call it the ER model. This is the conceptual framework for understanding data elements and their association. ER modeling is based on 2 key components, which are entity and the relationship, just like the ER. E stands for entity and R stands for model. An entity can be a thing or an object in the real world with independent existence and can be differentiated from other entities. Entities are normally nouns. We pick it out as nouns in the relationship. For example, we pick up author and book as objects in the real world, and those ones become entities. A relationship is basically an association between entities, and we pick them out by looking at verbs in a relationship. And another thing is our relationship are bidirectional, or they happen in both directions. An example is an author writes books, and each book is written by one author. So one direction of author to book is author writes books, and from books to author is each book is written by an author. So the wording there, the verb writes and written by, those ones are the relationship names. We have 3 popular ER notation: the chains notation, the UML notation, and the crowsfoot notation. Chains notation. We have rectangles as entities. We have ovals as attributes. We have diamonds as relationships. And of course, we have coordinates that can be numbered. UML, which is the Unified Modeling Language. We have rectangles with entity names inside as entities. We have lines as relationship, and we have attributes are listed within the rectangle. And of course, the cardinality is numbers of 1, 0, 1, dot, dot, asterisk. Let's look at that. UML is right over here. We said we have rectangles with names, okay, as entities. We have attributes written within the rectangle. We have relationships as a line, and we have notations as cardinalities. The notation we use, a 1 asterisk stands for n or any number or many number, and 0 also to stand for option. Crow's foot. Crow's foot notation, they have rectangles as entities. The lines with crow's foot symbols are relationships, and the attributes are listed within the entity rectangle. The cardinalities are pipes, single pipe, double pipes, and also just an O. Let's look at it. This is crow's foot. We said rectangles with entity names are entities. We said a line with crow's foot. Okay, looks like the crow's foot. Notation, those are relationships, and then attributes are written within the rectangle. Let's look at the business rule that is represented by all the notation. An example, let's look at the one-to-many example, and we can say that one author can write multiple books, but each book is written by one author. Let's see how this business rule is represented in each of these notation. Let's start with this. Our author, we always test with one. So our author or one author or a specific author writes. So we have a slash and a cross. So one or many, all these can generally be termed as many books. So an author writes many books. And this is represented in our statement here. One author can write multiple books. Okay, now if we are coming from the other side, we test one book. So one book can be written by exactly one author. So these two pipes generally are translated as one. Let's look at the change notation. Still test with one. Say one author writes many books. So here the multiplicity, we write it out as one many. Okay, one or many. M for many. You can also use N for many. So how about coming from the other side? We can say a book. A book can be written by one author or exactly one author. Let's look at how it is indicated in the UML. In the UML, we also say that one author, we always assume one when you're testing, say one author writes one or many. One or many are translated generally as many books. And let's see if you're coming from the other side. When you're coming from the other side, is one book can be written by 1.1 is either you say one and only one, or just say an author or one author. So you can see that these the same business rule but represented differently in this notation. The second business rule looks at many to many. And you can say an actor can star in multiple movies, and a movie can have multiple actors. So this is a many-to-many scenario. Let's see how it is represented. A many-to-many scenario in crow's foot notation, you can see the crow's foot notation on both sides is the same. So let's test one. When you say one actor or an actor, just say one actor can star in one or more, many, multiple. This is translated as just multiple. You can say an actor can star in multiple movies. Now let's go back. Okay, a movie can have multiple actors or one or more actors. Okay, this is how it is represented. Because it's the many to many, we represent it as M and N. Okay, so let's test one instance. One instance of an actor can star in any or many movies. Okay, and coming from that side, we say a movie can have many actors. Okay, let's see how it is represented in UML notation. In UML notation, we say still assume one actor can star in one or many movies. Okay, then a movie or one movie can have one or many, which is generally translated as many, or you can just leave it as one or many actors. Okay. And lastly is a one-to-one scenario. One-to-one scenario, we have an example of each user has a profile, and the profile belongs to one and only one user. If we just go to the diagrams and you see cross-foot notation, you can see the double pipes, which translate as one. They are on both sides, and you can test out one user has one profile, or one and only one profile, or a profile, or a specific profile. And one user profile belongs to exactly one user. Okay. Same here, we literally write it out as a 1-1, and you test the same thing. One user has one user profile, and the one user profile or a user profile belongs to exactly one user. In the UML notation, we can literally see it out that the notations are the same. The 1.1 appear on both sides of the entity. So you can say one user has exactly one profile, and a profile belongs to exactly one user. So this is how the notation look at. But we are, in this course, we are going to concentrate on UML for two reasons. One, it's widely used in computing and software engineering. And two, it provides details. It communicates a lot of details in our business roles. Let's look at basic example and continue pointing to a few of these components. Right now, an entity is a rectangle, and you can see it right over here. We have two entities with entity names, author and the book. Relationship, we say it's lines. Remember, we are just emphasizing UML notation. This is a line you can see right there, but one thing you need to know, it must have a name. So one, when you're assuming a relationship this side, the name is rights. When assuming a relationship this side, it's going to be written by. That's a relationship, and if you want to read it out, it's an author writes one or many books. You can see it, one author writes one or many books. And if you want to count from the other side, each book, one book, or each book is written by one and only one author. This is how it's represented. Attributes. Attributes define our entities. And if you look at each of these entities have an attribute. And when you look at the author ID, author name, and contact info, attributes in author, and then of course, these are attributes in book. Primary key, represented as PK, you will label them as PK in UML. So you just, the attribute besides it, you indicate a PK, and PK stands for a primary key. The primary key at this point is a unique identifier in any entity. A foreign key, we also label FK just besides that attribute. And a foreign key is an attribute that is a primary key in another table. So multiplicity is formatted with two notations. Let's call it X and Y. X stands for the participation, and Y stands for the cardinality. And participation can be mandatory, which is indicated as 1, and then it can also be optional, indicated as 0. And mandatory meaning that all the instances must participate in the relationship. And optional means not all instances must participate in that. And the cardinality can be too one or too many. Okay, too one or too many. Basically, it's the maximum number an instance in one entity relates to the instances in the other entity, meaning that the maximum can be one or the maximum can be many. Attributes. We just say that attributes define our entities, and we have different types of attributes. Let's start with a single valued attribute, which are also simple attributes. This can have a single value attribute, for example, an author name, which can be J.K. Rowling. Composite attributes. Composite attributes can have a hierarchy of attributes. When you look at this diagram, this is like the top hierarchy, then underneath is its components. Okay. These composite attributes need to be split into a single valued attribute for implementation purposes. Multi-value attributes. This can have a set of values in an entity. An author's contact information. An author can provide two contacts for number one and for number two. Multi-valued entities. And multi-valued attributes are represented with the curly brackets. Okay. And in this case, the multi-valued attribute here is the contact info. We have a derived attribute. Derived attributes are computed from another existing attribute. For example, in this case, we can use the birth date to generate our age. So you can see right there. Still noting here that composite attributes and multi-valued attributes must be handled differently for implementation purposes. We want to make a note here that composite attributes and multi-valued attributes appear differently in our relational schemas, and derived attributes should not be included in our relational schema for reasons that are concerned with the time variation. Multiplicity. We already seen that multiplicity is a combination of participation and cardinality and can be represented as that equation. Multiplicity is equal to participation plus cardinality. And we've seen that multiplicity is basically a combination of one notation, one digit, dot dot another digit, or call it x dot dot another x dot dot y, whereby the first digit is the max, the minimum, which is the participation, and then the other digits is the maximum. So when you look at this diagram, the first one is the participation, and the another digit is the cardinality. The same applies here. This is the participation, and this is the cardinality. Let's define each of these. Cardinality is the maximum number of times an instance can relate to instances in another. Okay, it's the maximum. So the maximum number of instances of author can relate to this. This is the many. The maximum number of an instance in book can relate to instances this year in author is one. Okay, and this we use those digits to basically determine the type of relationship. So you pick out this, you say one. You pick out this many, and you say this type of relationship is a many to one. Participation. This is the minimum number of entities that are involved in a relationship. And we say that 1 stands for mandatory and 0 stands for option. So meaning that an entity can be optional, can have optional participation, or can have a mandatory participation. And the digits that we can use for in the multiplicity is a 0, a 1, and the asterisk that stands for many or any number. More on relationships. We already seen that these are associations between entities, and they must be bidirectional or operate in both directions. They can be classified as one-to-one, one-to-many, or many-to-many. An example here in the first business rule A, we want to point out all this. In our business rule, we have an author writes one or many books. And we can literally say that an author writes one or many books. And if you're coming from the other side, we say that a book is written by one and only one author. A book is written by one and only one author. This is a business rule, and it shows how these two are participating. Okay, let's look at the relationship names. The relationship names here are pointed out as rights and written by. Multiplicities are near the book. Multiplicity near the book is one or many. Okay, this is not 1, 2, but it's one or many. So the multiplicity near book is one or many. Okay, and that's why we indicate it here. The multiplicity near author is one and only one. Here you can use the and notation, or you can just literally say are or specific. So we can say one and only one is the multiplicity. Now the other thing that I didn't include here is the type of relation. The type of relation, pick out this one and pick out this asterisk. And you say this is the one to many. This side is the one side and this side is the many side. And that is very important because we indicate our foreign key in the many side. After you establish which side is the one side and which side is the many side, then it's easier for you to move the primary key of one relation into the other to become a foreign key. So you can write out the business rule for B and C by pointing out each of the things. Point out the relationship names, point out the multiplicity near the actor here, near the movie here, near the author, and near the user, and near the user profile. You can work it out and see if you have mastered the concept. So we make a note here in multiplicity and the multiplicities in UML. And we say that one of the advantages of using UML is that it can be specific. We can use things like at least a specific number, at most a specific number. Now, let me give you an example of at most a specific number and at least a specific number. Basically, we say the most is 5. For example, if we look at most 5 authors, meaning the maximum is 5. So it's 0, 1, 2, 3, 4, 5. It cannot go beyond 5. Now, if we say at least 1, it means the minimum is 1. Okay? At least 1 can be 1, 2, 3, 4, 5, and anything. Now, if they say at least 5, meaning the minimum is going to be 5. So it's going to be 5, 6, 7, 8, and going further. So that's the beauty of using UML. And if you go to organizations that are specific, for example, scientific paper may not exclude 6 authors. So you may want to use, you go to specifics like including 6, as opposed to using the asterisk that stands for, yes, it can be any number, it can be many, but here UML really puts it out there for you. A key used for identifying purposes in a specific entity is referred to a primary key. Okay, and this is a unique identifier in an entity. It uniquely identifies a row in a table, and it can never be null. It cannot be null. If we look at our previous example where the author ID is a primary key in author and book ID is a primary key in book. A composite key is a combination, or it may consist of 2 or more attributes. For example, student number and last name. And many times the composite key is used because one of the attributes is not a suitable primary key. A surrogate key, this is a generated number for identification purposes, basically to act as a primary key. And it doesn't have to mean anything in the database. For example, an author ID can be generated as 89471, and that could be a unique ID number that uniquely identifies an author in an author entity. Our primary key enforces entity integrity. This basically means that there should not be duplication of records within that table. And that primary key should uniquely identify a record in that entity and can never be null. Still about keys, this time let's look at the foreign key. We say that it's an attribute in a table that references a primary key in another table. An example of our foreign key is an author ID that existed in the book ID. It can be null as long as it matches with the primary value. And primary key and foreign key must be of the same type. The most important thing here is the referencing, the correspondency between these two. And the foreign key helps us to enforce a referential integrity. And here, the foreign key must be matching with the primary key. The referential integrity must be specified between two entities. That is, a parent entity and a child entity. In this case, we have an author and a book entity. We say that there needs to be a correspondency between rows in these tables. And it must happen via a foreign key. And the foreign key in this case is the author ID, which we say must be valid or must be matching. This is an example of a college database conceptual design in UML. And we use an ERD, the entity relationship diagram, basically a diagram that consists of main entities and relationships. So you can look at this. This has been generated from the business rules. For example, we say a college stores information about students, professors, class sections, rooms, and courses. And the FAST Business School requires us to enforce a student must enroll in one or more. So we need to have, when you look at this, we have student and we have class section. So we point out those as nouns. So they nouns form as entities, okay, because we're looking at an entity relationship diagram. We're interested in entity and relationship. We don't have attributes here because it's just a conceptual design. You don't need to specify the details. So one student or a student must enroll in one or many. So one or many, you can see it, class sections are right here. How about if we go the other way around, which is but one class section is taken by many students. One class section is taken by one or many students, which is generally as many students. So you can see that this business rule has been accommodated in these two entities or by this relationship. Each class section is assigned a specific room. So let's look at the interaction between the class section and the room. So we point them out as entities. And the relationship here is assigned. So we can say one class section is assigned a specific room. And this is basically indicated by 1.1 room is right over there. And when we're coming from room, we can say each room can be used by several classes section. So you can say each room or one room is used by one or many, or generally say by many class section. This is also clearly indicated in here. Let's look at the third. Each professor may teach many class section. Each professor may teach or teaches may. Now we pick up may because it's option. A professor may not really teach, may be doing research work. So we say a professor may teach 0 or many class section. So you can see that this is taken care of with the teacher's relationship. So let's look at that going the other side. And one class section must be taught by one professor. One class section must be taught by one professor, or exactly one professor. Okay, and that is good. Lastly, we have a course has several class sections. One course has several, or you can say one or many class section, and one class section belongs to a specific course. One class section belongs to a specific course. So we don't have attributes here. We basically specify our entities and relationships in our UML conceptual design. So this is an example of a UML conceptual design, and you have an activity that requires you to pretty much draw something of the type given the following business narrative of a city book library database. Summary, looked at the design process overview. We broken down the ER notations. We looked at each component of the ER model, and then also looked at an example of a conceptual design given business scenario. And our next class is basically to zero down on how to create detailed ERD, or call it a logical level. Now, moving from the conceptual level, which are just shown in this class, now we're moving towards the logical design level.